Hello everyone, welcome to my presentation. From this screen, we can know that our topic for today is filters. So we are going to discuss about filters. Now let's see what is a filter. A filter is an electronic device or a circuit that allows the passage of a certain selected band of frequency components. Here, from the figures, we can get an idea what is a filter and how does it works. It allows a certain frequency to pass while eliminating the undesired frequencies. You might arise with a question that why do we use filters? Here is the answer. There might be some unknown frequency or signal associated with a desired signal. With the help of filters, we can reduce those unknown frequency or so-called noise. These are some practical use of filters. Filters are used in radio communication, audio electronics, DC power supply, analog to digital conversion. Filters are of four types, or they can be classified into four types. They are low pass filter, high pass filter, band pass filter, or band reject filter. Now low pass filters. Low pass filter is a filter that allows the passing of frequencies which are lower than a selected frequency. An ideal low pass filter eliminates all the frequency above a cutoff frequency. A simple low pass filter can be realized by an RC circuit. The time response of a low pass filter is found by solving the response to the low pass filter. Simple low pass filter, low pass RC filter. Using Kirchhoff law, we arrive at the following differential equation: V out equal to V in minus RC dV out by dt. The most common way to characterize the frequency response of a circuit is to find its Laplace transfer function is equal to V out by V in equal to omega naught by S plus omega naught. Now high pass filters. High pass filter is a filter that allows the passage of frequencies which are higher than a selected frequency. An ideal high pass filter eliminates all the frequency lower to a cutoff frequency. And here is the graph, so we can get an idea. A simple fast order electronic high pass filter can be implemented by placing any input voltage across the series combination of a capacitor and a resistor and using the voltage across the resistor as an output. The transfer function of this linear time invariant is V out by V in equal to SRC by 1 plus SRC. Now here we have come to band pass filters. Band pass filters allows a specific band of frequencies to pass by eliminating the above and the below frequencies. An ideal band pass filter have a completely flat pass band. You can have an idea from this graph. Uh, now, the bandwidth of the filter is simply the difference between the upper and the lower cutoff frequency. Q factor. A bandpass filter can be characterized by its Q factor. The Q factor is the reciprocal of the fractional bandwidth. A higher Q filter will have a narrow passband and a lower Q factor will have a wide passband. These are respectively referred to as a narrow band and a wide band filters. Band reject filters. Band reject filters eliminates a certain band of frequency and allows the rest to pass. It is completely opposite to a band pass filter. It also known as Notch filter. And Here from the graph, we can know that how a bandpass filter works. It's eliminate uh, a certain frequency and allowing the rest to pass. While in the graph, this is eliminating, while this is allowing this frequency to pass. A bandstop filter can be represented as a combination of low-pass filter and high-pass filter. If the bandwidth is wide enough that the two filters do not interact too much. The simple notch filter can be shown directly analyzed. The transfer function is equal to s square by omega z square by s square by omega p by q to s by omega p square. Here omega z is zero circular frequency, omega p is pole circular frequency, and q is q factor. And here we have come to the summary part. This is an original signal and these are some component frequencies. Here in the low pass frequency, it is allowing uh, the lower frequencies to pass while eliminating the higher frequencies. And in the high pass filter, it is allowing the high frequency band to pass while eliminating the lower frequency bands. And in band pass filter, it is allowing a certain frequency band to pass while eliminating the above and the while eliminating the above and the lower frequency bands. And in notch frequency and in notch filter, uh, it is eliminating a certain frequency. Here is this frequency, it is eliminated, and while it is allowing the low frequency band and the higher frequency band to pass. And here is the end of the presentation. Thank you.